I would like to start by acknowledging the traditional owners of the grounds at which I'm standing at the moment, to acknowledge the Turrbal and Yugara peoples as the First Nation owners of these lands, where we pay respect to the elders, lores, customs, and creation spirits. We recognize that these lands have always been places of teaching, research, and learning. This event, the AI 101 event, is very important to us. As you know, the Queensland AI Hub has started relatively recently. The Queensland AI Hub is a major investment of Queensland government, and KPMG, UQ, and QUT are the founding partners of the initiative. We are proud to be supporting this collaborative effort, and we want Queensland to be recognized as a leading location nationally and internationally, as a leader in AI-enabled social, economic, and workplace positive change. One of the four missions of Queensland AI Hub, one of the four pillars of the Queensland AI Hub mission is growth. And to read what the pillar says, we want to harness the talent across regions, innovation hubs, universities, industry, and government to maximize people development, skills utilization, investment, and global competitiveness. Ladies and gentlemen, my name is Marek Kowalkiewicz. I'm a founding director of QUT's Center for the Digital Economy, and I'm your MC today. We have fantastic speakers in the session today. We have representatives of KPMG, UQ, and QUT. UQ is represented by Dr. Sally Shrapnel. Sally is an interdisciplinary scientist working at the interface of causality and machine learning. She plays with quantum computing and artificial intelligence at the same time. To me, this is absolutely fantastic. She has studied biomedical science, medicine, surgery. So, you know, we have AI scientists who have studied surgery, biomedical engineering, and has been a registered and practicing medical practitioner for over 20 years. Sally will talk about that intersection of quantum computing and artificial intelligence. From KPMG, we have James Mabbott. James is the partner in charge for KPMG Futures. KPMG Futures is a forward-looking research and experimentation think tank within KPMG. Now, James is not your typical consultant. James is working very broadly with the community, with the industry, engaging in a number of initiatives. One of the initiatives that I found particularly interesting was his work on unlocking the potential, the fintech opportunity for Sydney, one of the research pieces in this space. And he worked to establish Sydney's first industry-led fintech hub, Stone and Chalk. On the QUT end, we have Professor Martin Obschonka. Martin is a psychologist. He's a psychologist working in the research fields of applied psychology, entrepreneurship, vocational behavior, economic culture, and social, economic, and technological change. What's interesting about what Martin does is that he's looking into this new perspective of AI stealing entrepreneurs' jobs. So he'll be talking to us a bit about the impact of AI on entrepreneurship. So these are our speakers. Once again, here they are, James, Sally, and Martin. And I won't spend much more time talking before handing over to James. The only thing I'll mention to you is in the Q&A sessions, section, you'll be able to ask your questions. Please ask your questions to any of the panelists. At the end of the third presentations, we'll start getting into those questions and discussing any of them that you might have. James, over to you.
Thank you, Marek, very much for that warm welcome. Okay, all right. I would also just like to start by acknowledging the traditional custodians of the land on which we are meeting today. In my case, that's the Gadigal people of the Eora Nation, and pay my respects to elders past and present. And welcome to anyone from our Aboriginal or Torres Strait Islander peoples who may be a part of today's webinar. Now, I guess in some ways, as Marek mentioned, I'm not the same as our other two presenters. I guess I'll be providing a bit of a skeleton, and then both Sally and Martin will be providing meat on the bones of what we're going to discuss today. And as part of that, there's really three things I'd like to cover through my conversation. The first one is why AI matters. And I guess I just want to provide a little bit of context to frame the conversation up, and also, I guess, touch on the current environment within which we are having the conversation today as well. Secondly, I want to talk a little bit about AI in its basic terms. So what is AI? What are the building blocks? What are some of the technologies that we're talking about in this context? And then where might some of those business opportunities be as we think about the Queensland AI Hub that we want to take advantage of in terms of building this out, because this is truly a fantastic opportunity for Queensland, this hub and this collaboration between QUT, the University of Queensland and KPMG coming together to help establish this hub. So the first place I'd like to start, I guess, is with what I call some of the hype. So we have this quote here from Sundar Pichai, where he talks about AI as being one of the most important things that humanity is working on, which is a pretty big statement. But I think underlining this is what he's talking about here is the potential to immeasurably improve our lives through the application of this technology. If we think about the big problems here, climate, poverty, hunger, health, mobility, water security, these are all things where the application of AI has the potential to give us access to new solutions and new ways of solving problems that we might not have thought about previously. But as we go through that and we think about how to get to this outcome, I'm reminded of this quote here from Professor Stephen Hawking. And in part here, I guess this is the hope aspect here, which is that if we're going to think about creating effective AI, and that this could be the biggest event in the history of our civilization, or potentially the worst, what Stephen is getting at here is that we need to be deliberate in terms of the choices we make if we want to realize the upside. Because intelligent machines will in some cases be faster, they'll be more accurate, they'll be able to operate cheaply and more safely than we can, and that this presents new opportunities. And potentially, as Marek outlined in his opening statement, and Martin will speak to, what are some of the implications here from an employment perspective that we need to take into account? And finally, we have this quote from Elon Musk, where he talks about artificial intelligence and this idea that we're in some sense summoning the demon, but really underlining this is a view that potentially we don't quite understand the risks as well as we could when we talk about AI, that there is a longer term existential threat here potentially. And in particular here, this is where we begin to see commentary where people talk about an AI application or a thing that is in some sense exponentially so much better than human intelligence, and that may present some sort of threat to us in terms of our long-term existence here on Earth. So that is the hype, the hope, and the horror. But perhaps we need to step back from that and ground ourselves a little bit in where we are today, and that is COVID-19. And I guess we've all experienced to some extent as we are on this webinar a degree of physical distancing and some isolation in terms of how we've been operating. Up on the top left-hand corner here, we have a picture of Sir Isaac Newton. And the reason I put that there was that in 1665 or thereabouts, there was the Great Plague in London. And during that time, Isaac Newton was in isolation. And it was during that period that discoveries such as calculus, gravity, and that the colour white is actually the combination of all the colour spectrums were made. And so as we come out of COVID-19 into what our new reality may be, it may well be there are new applications and new possibilities in terms of artificial intelligence and the technologies that it represents that we are yet to explore and implement and take advantage of. And I think that is something that we need to give some thought to in terms of how we move forwards in this space. So what then are we talking about when we talk about artificial intelligence? And today, in terms of the comments I'm going to make, I'm very much talking about the top half of this diagram. speaking to this concept of weak artificial intelligence or narrow artificial intelligence. So this is the idea there where we see the industrial robots. This is not a conversation about the image below where we talk about strong artificial intelligence or the idea of a super intelligence. I'm going to leave that very much to the science fiction realm from this perspective. So when we talk about artificial intelligence and the types of systems here that we're covering, we're really talking about systems that are capable of performing tasks that would naturally require human intelligence in order to complete them. And you can see here in this image on the left that we're talking about things like natural language, so the ability to listen and to speak in some sense. Ideas such as vision or image recognition, decision making, or the opportunity to augment or provide comprehension or self-learning, things that may assist in our own decision making. And unlike traditional systems, which may be programmed with rules or operate with structured data sets and provide binary logic outcomes, so yes, no type answers, with AI systems, we're talking about systems that are trained with examples, where we may show a machine, for example, a series of images of something in order to learn what that image is. So these may be non-traditional data sets. It could be video. We could be talking about emails or other forms of text. And then the outcomes that we get from these systems are probabilistic. So they ingest that data, they try and understand it, try and learn from it, and then put forward an answer that is based on a probability, not a binary outcome in that sense. So here we are talking about advanced analytics and algorithms that learn through using data from a wide variety of sources. And what we can see here, as I've mentioned, is those data components can be text, either semi-structured or unstructured. It could be images or speech. And when we look at the data that's available to us in the world today, around 80% of that data exists in things such as email, voice, text, and video. And so that's a very large source of data for which we could take advantage of in terms of designing AI systems. That data is then ingested, and through the use of algorithms, we try and learn through the application of that data. And then that learning through the use of having humans in the loop, we can train those machines to say, yes, that is the right answer, or no, it's the wrong answer. So again, if you take something like simple image recognition, where you have a machine and you're trying to teach it what an image of a particular object looks like, you may feed that a series of images and have an algorithm designed to learn the characteristics of that image, and then send it out to identify unique specimens. And when presented with those images, say, yes, that's right, or no, it's wrong. And so through that, the system can learn. And what this means in practical terms for us is the opportunity to automate things, or to accelerate our decision making, or gain access to enhanced insights. And the other big thing, I guess, that has changed over time here in this space is that no longer is it the case that you need to be a sophisticated computer engineer in all cases to make use of or apply these technologies, but there are a number of emerging tools and applications and platforms which make available to their users image recognition devices or natural language programming tool sets that enable ordinary users in some senses to actually build applications for themselves. And it is important, this idea that we keep people in the loop here, because there are certain characteristics that machines are not capable of learning at the moment. And here we are talking about common sense and things like empathy, which are very much human characteristics. And the reason this matters is because when these things go wrong, you need to have people in place in order to deal with that. For example, when we talk about image recognition systems, we've seen instances where they've failed to recognize people either on the basis of gender or race. And often that has to do with the training data that these systems are exposed to. For example, a lot of these systems are trained using images of middle-aged white men, much like myself, and then when exposed to images of people who don't fit that, often fail to recognise or can miscategorise those people. So the quality and diversity of the data set is really important, as is the interaction with people who can say, yes, that's right, or no, it's wrong. But having some awareness of that is very important. Or if you think about the deployment of chatbots and the people with whom they interact, we've seen instances through the use of social media where chatbots have become racist, misogynist, or sexist in terms of the comments they've made. And again, that depends upon the users and the data that they're exposed to and the level of quality assurance or oversight in terms of having people in the loop here. So to get to usable practical applications requires focus and the involvement of people in the design and deployment of these systems, but also the ongoing use of them as well from that perspective. And the reason this matters is because the size of the prize is huge, whether we're talking here in terms of the dollars, the amount of data that we'll have exposure to, the potential to save lives, or the skills or job potential that this might represent for our workforce. All of these are huge opportunities, and there are certain strengths that Australia may represent, whether it be things like autonomous mining operations, where Australia is a world leader, that may be able to leverage and be used in other fields, such as, for example, the exploration of space, where we know that through space travel and access to materials is going to be important, and to do so, autonomous mining operations may well play a very significant role in getting access to materials in planets outside of they're obviously outside, but when we work in an extraterrestrial environment, would be the more succinct way to say it. So what then are some of the real world applications? And I just want to touch on some of these briefly as we think about this in the context of the Queensland AI Hub and where we may actually be able to take advantage of this technology for the benefit of Queensland and Australia more broadly. And I touched very briefly on mining. Here, the increased productivity and safety operations that go hand in hand with this. And as I've mentioned, the linkage through to things such as the space industry, for example. So it's not just about efficiency, but effectiveness, but also potential for cross-industry translation that we should be looking at in the application of some of these technologies as well. Similarly, when we talk about agriculture or the farming environment, here we see an example of swarm farms autonomous technology, where you take things, for example, such as precision weeding, and through the application of robotic machines, image recognition, IoT, and communication between these machines, you're able to much more effectively weed a paddock, but equally you can do so in a way that is more sustainable and better for the environment as well. And the same for other tasks such as mowing or slashing or other things that can be conducted by a machine in this way autonomously that actually frees up farm labour for higher value add tasks in and around the farm environment. The third area I wanted to touch on was around the health applications that are there as potential. And here we have an example of the application areas of eye health, where we see people such as Google coming together and applying their very sophisticated AI technologies to look at eye health in the area of glaucoma and macular degeneration. And here, what's really interesting is that you can actually begin to detect changes very early on, and this means the potential for earlier preventative treatment and better outcomes for patients, and much more successful application of this technology. So in the health environment, there is a huge range of applications when we think about things such as image recognition, through to natural language processing, the ability to augment decision making and help identify issues much faster. And as I said, get on that preventative front foot and not just from a treatment perspective. The other one is in the COVID-19 area. A lot of conversation has been around the opportunity that advanced manufacturing represents. And So there is an opportunity here through the application of AI to create intelligent automation environments that actually create the potential for new industries to be explored. And here we have an example from a Tesla manufacturing line, where not only do the machines automate routine tasks, but the intelligence that is present through the use of AI is also used for quality assurance as well. And this means a much better outcome in terms of the safety, the effectiveness and the efficiency of that environment, but also means that we're talking about a high-tech manufacturing process. And this is something that we should be thinking about in terms of the AI Queensland Hub, is where are those opportunities for advanced manufacturing and how might we take advantage of those through the application of this technology. Another area that is really important to Queensland is in tourism, of course, and we've seen significant disruption to that environment over the last 6 months. And there is an opportunity here as we begin to talk about opening borders and the potential for tourism to come back in some senses, to look at different applications of AI and how that might be used to create better outcomes in terms of customer service, but also the welfare of employees in those locations too. And here we have an example of Josie, a humanoid robot that's part of the Munich airport system that provides directions to people and does so using unstructured interactions. So Josie has not been programmed with a series of pre-prepared Q&A sets, but actually interacts with people and learns from those interactions to refine the answers to the questions that Josie has asked. Another advantage of this is that by being part of a network of robots, all of the Josies are able to learn from each other and share those learnings very quickly, such that it seems like it happens real time to the people who interact with them. And so this presents a tremendous opportunity in that example. And again, we should be thinking about where are the applications here in a Queensland sense in terms of where we take advantage of AI technologies. The final case study I wanted to leave you with was this one from the financial services space, where we talk about AI for decision making, and this has broad application across a range of businesses and industries. And here we have an example where actually we're seeing that interdisciplinary borrowing of applications where genomics and particle physics applications have come together, in this case around a credit decisioning engine. And so again, I think we should be thinking about the opportunities for these things to actually come together and support more broadly those translation of opportunities across sectors and across industries and between disciplines as well. And I think that's one of the things that's really exciting actually in terms of what Sally's going to speak to and Martin's components as well, because we'll begin to create some of that opportunity for that cross-disciplinary learning. And the final thought I wanted to leave you with is that if nothing else, as we think about this, we need to consider how we manage data, the opportunities that lie here in terms of how we upskill our capabilities and create more opportunities for all of us. And importantly here is the role of trust in all of this as well. And one of the activities I've participated in with UQ for a while now is looking at trust and how that relates in an organisational context. And for the Queensland AI Hub, one of the key activities it will need to undertake in some sense is how you create a trusted environment within which to operate, because where we have low trust environments, we know that things take longer to achieve, and they can cost considerably more as well in terms of those applications. So there's a fantastic opportunity here for the Queensland AI Hub to make a difference in that sense as we think about the application of AI technologies in both business and society. And finally, how we think about the ethical use of these technologies as well. And so with that, Marek, I might hand back to yourself and to Sally to take us through the next component.
Absolutely. Thank you so much, James. This has been a fantastic presentation. Everyone, just a reminder, we have a Q&A section in the webinar available as well. Make sure you ask your questions in that Q&A session. I sent a message to every attendee, and hopefully you received this message from me. We would love to hear from you as you're listening to those presentations. What are some of your challenges? What opportunities do you see with artificial intelligence in your life, your business? There's a short link to a survey. You can try to fill it out during the webinar. We'll also resend that link after the webinar. You'll see that link probably about 15 times still today. Now, if you wanted to follow James, here I'm sharing his Twitter handle as well. Feel free to follow him on Twitter. And I would like to hand over to Sally, Dr. Sally Shrapnel from University of Queensland. So Sally, over to you. Feel free to unmute yourself whenever you're ready, and I'll stop sharing my screen.
Thanks very much, Marek. I'll just get my slides up. Great. So I just wanted to start by saying thank you very much, Marek, for inviting me to speak. And thanks, James, for that wonderful introduction. And I'd just like to say it's very exciting to be here with the AI Hub finally. I was involved in the very early days in the meetups, and when we had lots of UQ students and QUT students and very many people from industry all volunteering their time to try and build a community of AI enthusiasts and expertise within Brisbane. And it's just really wonderful to see all the hard work resulting in this great collaboration. So I was asked to speak about research in AI at the University of Queensland, and I have 10 minutes. So there's a large number of world-class scientists involved in a very diverse range of both foundational and applied research at the University of Queensland. This is not an exhaustive list. Many of the examples James covered in his talk, but I just wanted to put this up to give you a flavour of some of the research that's going on. Having said that, in 10 minutes, I can't possibly do justice to the depth and breadth of cutting edge research. So I've just decided to concentrate on 2 case studies. So the first is a project that started in January this year. And this was started by Professor John Fraser, who's an intensive care specialist at the Prince Charles Hospital and also a professor at both QUT and UQ. And he had the foresight to realise that there was an interesting virus that had appeared in Wuhan. At that time, it was known as the Wuhan flu. And he and a number of collaborators got together and put together an ethics approval for an observational trial to look at ICU data on patients with, as we now know it, COVID-19. So as we all know, the virus grew over the coming months, and so too did this study. We're at the point now where we have over 350 hospitals and enrolling institutions, over 48 countries, and each of these are collecting over 250 variables every day on each patient that's enrolled in the ICUs. It's a very large collaboration with multiple hospitals and also industry partners around the world. So who are we looking at in this study? We're not looking at people like this. It's not the mild end of the disease spectrum. We're not looking at people with mild coronavirus, but rather we're looking at people who are the sickest of the sick with COVID-19. So this study involves patients who are in the intensive care, who are requiring high-level supportive therapy with ventilation and various other techniques that intensive care specialists use to try and help patients make it through this illness and survive with good outcomes. So one of the things about this, as we all know now, is that it is a very new disease. It's not like SARS and MERS and other illnesses that we've seen in the past. There are a lot of unknowns about coronavirus, and it was obvious fairly early on that the usual ICU strategies weren't working. So we're really starting from a position of ignorance, and this is interesting for me to be involved in a study where clinicians needed information fast. Usually when you set up a study where you think you're going to do some artificial intelligence or you're going to do some data analytics, you take your time, you collect data over a long period of time, you gather the data, you clean it, and then you look at it. But what we're finding ourselves, we're in a situation where people wanted information as soon as they could. So it's a little bit different to usual. So we started off thinking, what kind of questions can artificial intelligence help? As you'll have gleaned from James's talk, prediction is something that we would be able to do. We are hoping that when we have enough patient data points, we'll be able to predict, for example, how long someone is likely to be in intensive care given their admission information. So you imagine a patient arriving in the ICU and you look at their other illnesses, their comorbidities, their demographics, their age, what medication they're on, their biomarkers, and can you put all that information together and produce, using artificial intelligence, a predictive tool that will give you some idea of how many resources this patient is going to consume. Will they need to be ventilated? How long will they need to be ventilated? Are there any particular risk factors that you can identify that will make it more likely for that patient to do well or not do so well? So these were all the kind of questions that we started looking, how are we going to build tools to be able to answer these questions? The truth, of course, as everyone knows, is that 90% of artificial intelligence is about cleaning data and getting your data into the right shape. So this was our reality for the first months of the project. It's a particularly unusual situation in that typically when you do a clinical trial, you're in a very well-controlled situation. But the reality for many of the countries that are inputting data for this coronavirus study is that the health professionals that are usually put in the data are exhausted. They've been working in PPE all day, long shifts, and the last thing that they want to do at the end of the day is input 250 variables into a REDCap database. So we've done a lot of work and we've been very blessed with lots of generous pro bono support from industry, Amazon Web Services, various people helping us to try and get good quality data in so that we can start the process of doing the learning. One of the other things that we did was we realized with 250 variables, we pretty early on needed a tool to be able to visualize the data. So we built a dashboard which shows basic statistics, violin plots, this kind of thing, so that the people who are entering the data could very quickly be getting some return and looking at basic relationships. What was interesting was we were able to see certain fields that weren't being filled in well and able to track back to why that was the case. We're able to look for some unexpected relationships, differences across country, gender, outcome, etc. So what's happened with this tool now is that, again, we've been very fortunate. We've had a huge amount of support, pro bono support from IBM, who are helping build a much better and more scalable product so that hopefully we're going to be able to get this information, and once we have the models going, get this information to clinicians at the bedside. So coronavirus is a little bit of a morbid topic. So for my second case study, I'm going to look at something that's a little bit cooler and more exciting, and that is quantum enabled artificial intelligence. So I guess you must be wondering, you know, most people when they think of quantum mechanics, they think of, you know, weird, spooky action at a distance, particles that can be in more than one place at one time, cats that are both alive and dead at the same time. So it seems unlikely that we might be able to use quantum mechanics to help us with artificial intelligence. But in fact, we are in the midst of what those of us in the field call the second quantum revolution. Quantum technology has improved in leaps and bounds in the last 5 years or so. It's really incredible the pace of change in this field. The picture on the left is a teleportation setup from around 2015, an optical table with various lasers and mirrors and beam splitters, etc. And here's the same setup a couple of years later in a little waveguide, etched into a little waveguide. So the pace of change has been extreme. One of the things that we have been working on, and many people around the world, is building quantum sensors. And we now have actually in practice quantum sensors that can effectively make the invisible visible. So things that have been unable to be detected in the past, we now have quantum sensors that act at such precision that we can see things that we weren't able to see before. One example is that it's a considerable risk to companies when they're drilling or building structures underground. If there are underground structures or mines or tunnels, this can be considerably risky. And you can actually use you can measure the tiny fluctuations in gravity using quantum sensors that are caused by underground structures to map the underground areas within cities. You can monitor volcanic activity by, again, measuring tiny fluctuations in gravity caused by when magma channels fill up. We can visualize very sensitive, fragile biological specimens using quantum light. And this is just a couple of examples of how quantum sensors can help us see things that we couldn't see before. Quantum computers are the other obvious advance. Quantum computers enable us to look and find patterns in data that we can't see using classical computers. And this is one of the new proposals for early quantum devices, not the full-scale quantum computer that's still 10 years away, but early small-scale noisy circuits, is to use them in specific quantum learning applications. So of course, if you think about having quantum computers, a kind of quantum brain, and quantum sensors, the natural thing is to wonder about whether we can build quantum robots. So is it possible to have a quantum agent that is equipped with sensors that can see things that humans can't see, and then also equip them with quantum processors and quantum computers so that they can see patterns within this data that we're unable to see? So this is fairly theoretical work still that's going on at the moment at the University of Queensland in the ARC Centre of Excellence for Engineered Quantum Systems, and it largely funded by the Foundational Questions Institute, a large philanthropic organisation. But we're slowly moving from theory to application and asking ourselves, what are the opportunities and what are the risks of building such super quantum intelligent agents? So I'll finish there. I think that's my 10 minutes up. Thanks very much for listening. If anyone's got any questions or wants to follow up on any AI that's going on at UQ, you can contact me at the email address there. So thanks very much, and back to you, Marek.
Sally, thank you so much for this fascinating presentation. Please follow Sally's research. There's a number of outlets you can find her research in. Really exciting. I have to say, whenever I hear quantum computing and artificial intelligence in one sentence, I'm all drooling. So thanks so much for this wonderful introduction to this exciting space, Sally. All right, look, let's head over to Martin Obschonka and try to understand that cross section of AI and entrepreneurship. Martin, this is over to you. Let me stop sharing my screen. Oh, and before I do, two great questions in Q&A, please add. We'll be discussing them very, very soon. Martin, over to you.
Thank you very much, Marek. Let me start the slides. So thank you for the invitation, a really great initiative, the AI Hub. I think it's clear that we live in the second machine age. So now it's not about the Industrial Revolution, but more about data, AI, and that, computers can outperform humans or even supersede humans. And I'm the director of the Australian Centre for Entrepreneurship Research at QUT, also associated the Centre for Future Enterprise QUT. So this is the business school, and I'm interested in entrepreneurship. And yeah, what can AI do for entrepreneurship, you can ask. And of course, entrepreneurship is relevant for the Queensland economy, for the economy in general as a job creator. So here, this is data from the ABS showing that substantial share of new jobs are created by young firms. So these are startups. So startups are a major job creator. And here you also see the drop in 2009, the financial crisis, and then afterwards the recovery of the economy. So the idea that entrepreneurs create jobs, but then there's this idea that AI may substitute or replace people, individuals. So it's this question whether AI might also substitute entrepreneurs, replace entrepreneurs, or might AI help entrepreneurs to be better, to be more efficient, to be more effective, and maybe to even create more jobs. So that's kind of the starting point of my research. And I just want to give a brief overview. I know it's just 10 minutes. What we're doing right now, kind of insights into the lab, so to speak. So in entrepreneurship research, we typically study the entrepreneurial process. So, and this is centered around the opportunity, right? The opportunity, the idea, the business opportunity, kind of the three-stage process: prospecting. You have to find a new idea. You have to find the opportunity. Is it already there? Is it co-created? You have to develop it, evaluate it, maybe decide on one and invest more resources there. And then, so to speak, the startup phase, the venturing phase. So, and then we have the entrepreneur, the people side, the human agency, and the environment, and both interact with each other. And let's focus on the opportunity. So is AI the golden opportunity, maybe, right? Is it itself an opportunity? And these are pictures of I think the Victoria Gold Rush and the California Gold Rush. So it's really something there, the gold fields, so to speak, the tangible opportunity, but it also requires the human agency, the risk takers, the creativity, people that take action and initiative. So again, an entrepreneurial process. And of course, today we see a lot of momentum around AI startups. So startups that use AI, entrepreneurial projects that use AI. This is data from the US. We also have it in Australia. I think I counted around 400, 500 AI startups in Australia. So AI is already kind of a subject here. And then if we look at the environment, and so in research developed by my colleague at the Australian Centre for Entrepreneurship Research, Per Davidson, we typically see it as an external enabler. So it enables new entrepreneurship. It's a new technology, new developments, new progress that allows certain startups to be quicker, to be faster than incumbents, bigger firms, to start something new, to have something truly new under the sun, and to be more entrepreneurial. It might also affect the roles here, so it could trigger new entrepreneurial projects. So it could stimulate, the ideation, so to speak. It might shape the product, the venture as such, or the entrepreneurial process, but it could also be outcome enhancing. For example, it could help startups to scale, right? To approach other markets, to be more effective, to help with their business operations. So again, if we go back to the entrepreneurial process around the opportunity, right? Opportunity identification, opportunity evaluation, opportunity exploitation. If that is the core of entrepreneurship, which might create new jobs. So we are currently running a bigger study how AI might help entrepreneurs in these three stages. And these might be different mechanisms, different effects. So how can AI help in the ideation effect, finding opportunities based on big data, access to big data that can be transformed into information, business information in the creative process? How can it help entrepreneurs to evaluate these opportunities, to make rational decisions, the human judgments, so to speak, but also then in the startup process. So we currently have a larger survey with tech entrepreneurs around the world, where we want to find out how can AI help basically every entrepreneur to be better in that entrepreneurial process. But then the people side. So of course, and we already discussed this, James discussed this, for example, the human side, the people side. There's no entrepreneurship without entrepreneurs. Can there be an entrepreneurial algorithm? And from research, we know what the challenges here. For example, entrepreneurs need prior knowledge, right? Industry knowledge about entrepreneurship. So maybe AI can help them, given that there's access to data, big data, information, to gain more prior knowledge before they start new ventures. Or cognitive bias. For example, we know overconfidence. Sometimes entrepreneurs show overconfidence, that they think they make the right decision, but it's not based on the actual available information, so that it can also support entrepreneurial decision making. Another thing that I also study is entrepreneurship as a private trait. So we look at the personality, passion, like the personal identity profiles of people, and how this might make them more entrepreneurial or more successful. And we know already from research, for example, if you use social media data, this is an analysis my colleague Michał Kosinski at Stanford did. You see him here speaking at our Entrepreneurship Research Conference, analyzing my face, that if you only analyze 100 Facebook likes, it tells you more about your personality, so to speak, as a user, than your family member, friend, work colleague would know about your personality. And also, of course, face and analysis and other AI techniques can tell a lot, or can find out private traits, and can therefore also be linked to entrepreneurship and to entrepreneurial traits. So that is another kind of fascinating research topic, but there's also an ethical issue involved. We also analyze social media, of course, for example, from successful entrepreneurs, and like AI-supported text analysis to learn about their personality, their thinking, their decision-making. For example, we did that with 1.5 billion tweets in the US, translating Twitter language. You know, we knew where this was treated from into psychological traits, into an entrepreneurial personality, and then we could create kind of a psychological map of the US based on AI, and that overlapped almost perfectly with the economic map that is the startup map of the AI. So there's this AI-supported research going on entrepreneurship and the entrepreneurial kind of personality. Last but not least, AI might also help with entrepreneurial finance. Often ambitious projects need angel or seed funding in the earlier stages, and later growth stages, venture capital. And what we know, for example, is that we see this in entrepreneurial pitches when, you know, entrepreneurs have to pitch their ideas to investors, other people. AI could help them to become better with that, right? To be more effective, but also investors could use maybe AI to, you know, find more promising projects. So that is another promising field where we can apply AI to make the entrepreneurial process more effective, more efficient, and therefore maybe to create more jobs and be more resilient in the local economy. Thank you very much. Just a quick insight, and feel free to contact me or our center if you want to learn more about this or interact with us. Thank you very much.
Martin, thank you so much for this presentation. If I could ask the panelists to now bring their cameras up, and I'm going to unmute all of them if I muted any of them. We're seeing some very interesting questions in the Q&A section, and I wanted to start by a question that was asked by Ivano about the title of the event, Demystifying AI, and the question of what are the AI myths that we should be mostly aware of. Now, I'm going to slightly rephrase this question, and I'm going to ask each of our panelists to tell us some of your favorite stories about human beliefs or you know, broad beliefs into the power of AI that are simply not true, or simply not true just yet. Is there anything that you would like to share?
Yeah, I've got something I can share. So one of the things that I hear frequently is that AI is a black box, and we can know nothing about how AI works, and it's this incredible mystery, and you know, it's just an algorithm. You plug in the data and you get the answers out the other end, and we just have to take it on face value that's right. And of course, that was probably true not so long ago, but now we have a large number of different techniques that we can use at all stages of the machine learning and AI pipeline to try and improve our understanding of how the model is coming to the particular conclusion that it has, whether that's looking at biases in the data in the first place, whether that's looking at different features that are important during training, during validation, the differences in the test set, and a whole host of other techniques that we can use now. And I think what that means is that this original idea of AI replacing people is just really not going to be true insofar as because we can actually look at all stages at how the models are working. It means that there will always be an opportunity for humans to be involved and to be improving the models and to be changing and addressing which way we want the models to go, etc. So I guess I guess the myth is it's a black box. We can't know anything about it, and it's on there on the shelf doing its own thing.
That's quite reassuring to hear that we're not going anywhere just yet, Sally. Thanks so much. James, Martin, did you want to add to this one, or are we jumping to another question?
We can ask whether AI is really new, right? So it's probably not really new. There's a long history. What might be new is the new accessibility, is maybe the new big data, amount of data that is available, and the power of computers.
Excellent. Thanks, thanks, Martin. Let's jump to another question. I'm going to jump to a question that Darren asked, and I thought, James, you might be in a great position to address this question. Darren is talking about this challenge of AI combined with robotics, so that sort of embodied AI, as we would call it. We're starting to see some of the jobs being disrupted, and Darren is talking about quite a broad spectrum of those jobs. He's asking whether we see it as a sovereign risk to Australia, and whether that combination of robotics and AI is perhaps one way of trying to address that risk. And James, we're going to try to unmute you.
Can you hear me now?
Yes.
All right, brilliant. I thought I'd unmuted myself. I did not have the power. You did, Marek. So I think, it's an interesting question. And I think it comes back to the myth question as well. I think the conversations around jobs and the implications for jobs are interesting, but they're always forwards looking, right? The big disruptions haven't happened, which is a good thing. But it's a forecast into the future, and I think it's not right? We're not correct in making those predictions. So I think that's one of the things here that we need to bear in mind when talking about this. But coming to Darren's specific question, I think, and he's partly provided the answer within the question, is that there's an opportunity here for us in Australia to get on the front foot in terms of how we approach topics like advanced manufacturing and the things that AI embodied within robotic machines actually presents to us as a nation, and use that as an opportunity to spur our advanced manufacturing agenda. And I think that's received another accelerant at the moment in the terms of what's happened with COVID-19, because now a lot of organisations and countries are looking at their supply lines, particularly into China as a manufacturing destination, and saying we need some diversity in terms of our manufacturing supply. As part of that, there's an opportunity to look at reshoring of some of those manufacturing and supply capabilities. In the case of us, I think it naturally makes sense to do so in an advanced manufacturing context, because the labour costs are what have driven some of those activities offshore. And if we don't find a more efficient and effective way to do them, such as the application of robotics, then we won't be able to reshore those capabilities. So there is a very real opportunity in that sense if we want to pursue it. And I certainly think, personally, if I was looking to create an opportunity for the Australian manufacturing sector, I'd be looking at the application of AI and robotics and what that might mean, both in terms of advanced manufacturing, but also the goods that are manufactured and where they might be applied more broadly within our economy, and the export opportunities that come off the back of that as well.
Excellent. Thank you, James. One of the questions that we're seeing in the Q&A on top of the list at the moment, and it's very much a question also to the core team running the Queensland AI Hub, so not just the founding partners that are UQ, QUT, and KPMG, but also the AI Consortium. It's a question around collaboration, and the anonymous attendee asking this question is asking basically to capture the nature of this question, whether there's any benefit or need or whether we should be focusing on making sure that all sorts of hubs that are operating in this space of new technologies across Australia should be collaborating. Question to everyone in the panel, who would like to start?
We're all very polite, Marek. I think, look, for mine, naturally, there should be collaboration. I think if you're going to have people pursue the application of these technologies and opportunities, you'd want to do so in a coordinated way. The way in which we might think about developing AI applications that have the potential for application in the space industry, for example, you'd like to see that coordinated, or in terms of the robotics hub, how that might come together, and that way we make sure that the money that's spent gets the best possible outcome as opposed to spending on the same thing in 3 different places. So from my perspective, I think collaboration would make a lot of sense.
Yeah, I would agree. I think naturally, obviously, you want to have some collaboration across any groups where there's potential for replication. One area that's interesting to consider, though, would be health. And this is obviously a very big, interesting industry growth area in AI, and that is the application of AI to digital health. We're collecting electronic health records everywhere now in Australia, but Queensland's kind of really ahead of the game there. And we have this very rich electronic health record that we're collecting. And so it does make sense, I think, for digital health and AI to start off with a state focus. Obviously with an eye on collaborations as time goes on, but we're in a reasonably unique position to be looking at that in isolation to start off with.
Yeah, I would also totally agree. It's kind of a capacity building, right? Such a collaboration for the ecosystem, for the region, but also to make us more informed as a region regarding ethical decisions and ethical challenges. So if we have all the data about individuals' health history, for example, what happens with that data? Who can analyze that data? What do I disclose as a patient, as an individual, just by going into a room and there's a camera or a microphone, or I write something down? And that we all learn more about this, in a kind of in this hub environment, so to speak, and in stimulating environment is probably the essence of an agile economy and society.
Thank you, Martin. We have quite a few more questions here in the Q&A section. We are not going to be able to respond to all of them, but we're going to capture them in many various ways. We're going to respond through the Queensland AI Hub channels as well. I think there was one that was quite interesting as well, and I'm not going to ask for any responses from the panel, but I just wanted to flag this this question, and again by an anonymous attendee, flagging that we need more superstars. We need more AI superstars in the Australian ecosystem, and that attendee has kindly mentioned distinguished Professor Peter Cork, who was recently awarded an IEEE award for his fantastic research in the robotics space. How many more such names and those leaders in AI can we create? This is the question. And through this collaborative approach, just see what's happening here. Just see what's happening right now. We have universities that in some other spaces are perhaps competing. In this space, in the Queensland AI Hub, are collaborating and working on building a greater ecosystem. We're spanning the entire country. It's a national initiative, and we're trying to bring partners from other states as well. So I would say that in many ways, our approach here, the collaborative approach, is really distinguishing us and making us stand out as that community. Ladies and gentlemen, our goal is to finish not later than 4 p.m. So I wanted to first thank the panelists. I wanted to thank Sally, James, and Martin for your wonderful presentations. I wanted to thank the attendees for exciting questions. I wanted to thank those of you who already responded to the survey that we shared with you in the chat. You will see the link a couple more times. When you log out of this Zoom meeting, you'll see the link to the survey once again. When you receive an email, a thank you email from us, you'll see the link to the survey once again. This is part of the bigger process right now, which helps us design the future of Queensland AI Hub. And many of us, some of us here in this seminar, are also going to take part in a virtual design jam on Wednesday, where we're going to spend a few hours together in a virtual space trying to shape the future of Queensland AI Hub. If you're interested in joining that, we still have a few, very, very few spots available. If you are able to devote a few hours of your time on Wednesday, you will receive a link to this one in our communications as well. Stay in touch with us. Queensland AI Hub can be reached through Twitter, Facebook, LinkedIn channels, obviously the website as well. I wanted to thank all the founding partners and the partners creating the AI consortium that are forming the entire initiative. I wanted to thank Queensland government for their ongoing support in this initiative. Ladies and gentlemen, Sally, James, Martin, everyone, thank you so much for spending this 1 hour of your life with us. Have a wonderful evening, and we hope to see you soon. Goodbye.